lesson's about finding area of regular polygons. What's a regular shape? What's a regular polygon? All sides and angles are equal. What's one regular polygon off the top of your head? Square. That's a standard one. But we're going to really be focusing on regular pentagons and regular hexagons and so forth. Those are the ones we're really going to focus on because we already have formulas for squares. Today we're going to start off with these vocab words though. Center of a polygon. So if you have a shape that maybe looks like, let me bring up a shape for you. I will start off with pentagon. If you have a regular pentagon that looks like that, where is the center? In the middle. Okay, it's kind of vague. They say in the middle. I think I know what you mean. You mean here somewhere. How would you describe the middle, though, the center of a polygon? All the lines cross? Okay, so it's the point. I like what you said, Albert. It's the point that is equidistant. Good math word. From the angles. So that means all these distances are going to be the same. That's what it means. You don't have to draw those lines. I'm going to undo them actually. I'll leave one of them. Radius of a polygon. This is why I just wanted to leave one of them. Okay, a radius of a polygon goes from your center to your vertex. So it's a segment from the center to a vertex. Not bad. New word. How do you say that? What do you say, Poe? Apothem. Not an opossum. Apothem is what it's called. Yeah, a little bit of a lisp. All right, so here we go. It goes from the center to the midpoint of a side. So it's a segment from the center to the midpoint of a side. Not too bad. The last thing we're going to talk about is central angle. Central angle. And we kind of already have it drawn. It's this angle that we've created that's between what two segments? Okay, so it's the angle that's created by the radius and apothem. That's your center angle. This picture is key. Anytime you're dealing with a complex regular polygon like a pentagon, hexagon, octagon, you have to draw this. Your radius, apothem, and central angle. Radius, apothem, central angle. That is important. In example 1 it says, we have a regular hexagon that's inscribed in circle G. It says, find each angle measure. The first angle measure comes from EGF. So EGF. That's separated between two radii. How do you think you do that? 360 divided by number of sides. That's a good way to do that one. How many sides? 6. So that angle is going to be 60 degrees. That's exactly how I would do it. Okay, so the next one, we do EGH. Oh, that's over here. Okay, so if this first one is 60, the second one is just half of that 60, which is 30. The last one is HEG. HEG. So that is going over here. So you should be able to see kind of this triangle. This one we found was 30. That's 90. This one has to be 60. Okay, and I want you to write some special words beside some of these. This EGF has a special name. And really, that is the central angle. I kind of misled you on the last one because I want you to focus on a different one. This one is the central angle. It's between two radii. Change that in your definition. Instead of radius and apothem, it's between two radii. But part B is the half central angle. And this is the one I want you to circle because it's the most important angle we can deal with. That is the important one. It's the half central angle. Central angle is easy to find. You just do your 360 divided by 6. But the half central angle is the one that lets us find a lot of parts. Any questions? Now it's time to start talking about the formulas for these regular polygons. There are two formulas. The first one we're going to talk about is 1/2 apothem times the perimeter of the whole shape. That's little a, big P. Apothem times the perimeter. That can kind of be simplified to this. Apothem times, how do you find the perimeter on regular shapes? Add up all the sides there. I like the multiplication way better. Number of sides times side length is the other way to do it. So N, once again, is number of sides. And the S would be side length. What was that A once again? Apothem. I think you're getting that. Apothem. We're going to practice this on example 2, and I'm going to point out the key parts that you have to be aware of. I'm going to take this and put it in a new page. That way we can just focus on the picture. Here we go. Here's the key stuff we need. It says a wooden coaster is a regular octagon with 3 centimeter sides and a radius of 3.92 centimeters. What's the area? So first off, you got to know, what is this number? It's the radius. It's from R to Q. But I said you have to be able to draw something special on that shape. You have to be able to draw the radius and the apothem. And that makes a little right triangle that you should draw out to the side. On that right triangle, we should be able to label some parts. We should be able to label some parts. Where's that go, though? Where's the 3.92 go? It's the hypotenuse. If you look back at the picture, it's on that piece right there, which is the hypotenuse. This goes down to the middle of the side, making a 90-degree angle. 3.92, sorry. Now, we should be able to find some of the other parts. It says, oh, it has 3 centimeter sides. That means this whole side is 3. I don't want the whole side. I just want this little part over here. That's half of it, which is 1.5. Good job. The last thing I need to do is I need to find the apothem. Pythagorean Theorem. Good job. I heard that. How do you start off our Pythagorean Theorem? 3.92 squared equals 1.5 squared plus a squared. Now, calculator time, since we have a lot of decimals, type that in your calculator. Make sure you can keep up on this. You may. For the whole thing, or just this part? 15.36 equals 2.25 plus a squared. We subtract the 2.25, and we get 13.6 13.35 equals a squared. To get a alone, how do we get rid of the square? Square root. Good job. When you square root that number over here, you get 3.65. 3.65. 62. 65. That's the difference. Did you do the square root of this 13.35? 13.116. And then you get 3.62 for the apothem. That can be plugged in right here. 3.62. Now we are ready for our formula. And I like this formula right here. 1/2 A N S. Because I can remember A N S. It's like 1/2 answer. This is kind of how it clicks in my mind. The area we don't know. Do we know the apothem to plug in for A? Yes, we just found it. That's the 3.62. N stands for what? Number of sides. How many sides do we have? Oh, it's an octagon, so that's 8 sides. And then S stands for side length. Length of one side. The whole side is 3. Multiply that. Tell me what you... All right, so we get area is 43.44, and units on our answer? Great job, centimeters squared. Good job. All right, the next thing I want you to do is try these checkpoints. See if you can take your time and get the answers correct on these. All right, here we go. Checkpoint number 1 in the diagram, you have a square inscribed in a circle. Find angle FKJ. It's good to outline it if you haven't already done that. So outline FKJ. What's that angle called? It has a special name. It's called the central angle. It's when you use 2 radii. That's how we rephrased our definition. So to find a central angle, we had a formula that somebody spoke about earlier. What was that formula? 360 divided by number of sides. And you get 90. That central angle is 90 degrees. The next one is to find KJF. KJF. So let's focus on that one. K going down to J and then over to F. So it's really focusing on that angle. What I always like to do is kind of sketch a little picture. They took this triangle. It looks like this. They cut it in half. So that took this 90 and cut it into 2 pieces. Oh, they're both 45s. Well, if that's a 45 and that's a 90, what's this other one have to be? It's another 45. That angle is 45. That's the important one. That is the important one. The 45 is that half central angle that we really need for our solving. Number 2 says the radius of a regular pentagon is about 6.8. It drew it on there. Find the area. First step, you need to be able to draw that little right triangle out to the side. You always need to be able to do that. So we have the right triangle from our picture. This piece is our 6.8. Oh, and then it tells us the whole side is 8. Do I want the whole side? I want half of it, which is 4. I'm going to find the apothem by using what? Pythagorean Theorem. So that would be 6.8 squared equals 4 squared plus A squared. What do you get for A when you solve? So final answer for A. All right, so we get the apothem is 5.5 inches. Now we're ready to do our big formula. That's 1/2 ANS. So area equals 1/2. What's our apothem? Yeah, we just found it. Number of sides, 5, times our side length. Oh, our side length is 8. That was indicated over here. A whole side is 8 units long. When you multiply that out, you get area equals, one more time, slow down. We'll say approximately 110 inches squared. Okay. All right, here's our last example. It says a regular nonagon is inscribed in a circle with a radius of 5 units. Find the perimeter and area of a nonagon. First thing, you look at that shape. Nonagon means how many sides? 9 sides. So the key thing is being able to draw that triangle I talked about. That goes from the radius, apothem, and then that half side. That's the triangle you must draw out to the side. So we can label a 5, and we don't know these other pieces. We don't know them. We got to be able to solve for them, find them, using trig. So here we go. First step, let's find this angle. To get this half central angle, we've got to find the whole central angle. How do you find the whole central angle? 360 divided by 9 is 40. But I don't want the whole central angle. I want the half angle. So half of that 40 is 20 degrees. Now I have everything I need. So we have a choice. We can solve for this A, or we can solve for this missing half side. Let's do the A first. I agree. So using trig, we got to label our sides with OAH, opposite, hypotenuse, adjacent. What is our X? Opposite. Our 5 is hypotenuse. The adjacent side is always between the angles. The adjacent side is always between the angles, and it's A. That's how it works out. So to solve for the A, we need to use our A and our number we already know, which is our hypotenuse. A and H for trig, that's adjacent and hypotenuse. Cosine. So we say cosine of angle 20 is A over H, and we know H is 5. From here, the first step that I'd like you to do is realize that this is a number, cosine of 20, and then its cross, when we're cross multiplying, is also a number. So if you do A times 1, which is 1 cross, you get A. The other side is just cosine of 20, and then multiply by 5. You don't need to round 2 times, you just round once. 4.69. We'll take that. Stop there. Now we need to find our X side. We have 2 methods. We have Pythagorean Theorem, or we can do trig one more time. Pythagorean Theorem then. That's what I keep hearing. So let's start off with c squared. Our c is our hypotenuse. How long? 5. So we do 5 squared equals, we just found the other side, 4.69 squared plus x squared. Solve for x. All right, so once we solve for x, we get x is 1.73. That's the piece we need. So what we're going to do now is we're going to do our formula. Our formula, once again, is that 1/2 a and s. So 1/2, our apothem is how long? Yeah, we already got that. That's that 4.69. Number of sides, that's the n. How many sides on a nonagon? 9 sides. And then S. S is a whole side length. It's not 1.73. Oh, it's 1.73 times 2. Type that whole thing in and tell me what you get for area. 73 point what? 02. And then put our units on it. Units squared. All right, here's a recap of this problem. The first thing we did is we found the little triangle that we're supposed to find that uses the half central angle. So we first found the whole central angle, which is 40, took half of it to use on our special triangle. We then labeled what we knew, which was a 5, and then we had 2 pieces we didn't know. I didn't call this S because it's not the whole side. I called it X. This piece right here was our apothem. We then discovered that we needed to use trig, which is labeling sides opposite, adjacent, hypotenuse, and we did that with our O, A, and H. The next thing, we pick the correct trig function to find the apothem, which deals with adjacent and the hypotenuse, which is cosine. We cross multiply to solve for a, and we got 4.69. That's our length of our apothem. We then needed to solve for our other missing piece, which is our x. We need that x so we can get the whole side length. So to solve for x, we use the Pythagorean Theorem to solve for that little half side length, which came out to be 1.73. We then plugged into our formula, 1/2 a n s. This a is our apothem that we already found. This 9 is our number of sides. And then this piece right here is the complex part, which represents our side length, s. And it is 2 of these half sides. So 2 of these sides makes our whole side in our picture. That's the most complicated part that people generally miss.